Welcome to chemistry classes by Vijay Kumar Sethi, class 12th chemistry. We were discussing chapter alcohols, phenols and ethers, and in this video we will discuss about structures of functional groups like alcohols, phenols and ethers. First come to alcohols. In alcohols, the oxygen of the OH group is attached to carbon by a sigma bond, and this bond is formed by the overlap of a sp3 hybridized orbital of carbon with a sp3 hybridized orbital of oxygen. You can see in this structure, this is a sigma bond, okay, and this carbon is sp3 hybridized, and this oxygen, this is also sp3 hybridized, okay. The bond angle COH in alcohols is slightly less than the tetrahedral angle, that is 109.28 degree, and this is due to the repulsion between the unshared electron pairs of oxygen. Now, when this is sp3 hybridized, arrangement of electron pair is tetrahedral, but due to the presence of these lone pair of electron, this is bent shape, this, okay, and again due to the repulsion between these lone pair of electron, this bond angle is slightly less than normal tetrahedral angle. As we know, repulsion between lone pair of electron is more compared to the lone pair bond pair, and lone pair bond pair repulsion is more compared to the bond pair, okay. In phenols, the OH group is attached to sp2 hybridized carbon of an aromatic ring. Now this oxygen of OH group and this carbon of benzene ring, this is sp2 hybridized. The carbon oxygen bond length 136 picometer in phenol is slightly less than that in methanol 142 picometer. You can see this bond length, okay, this is 136 picometer, while in case of methanol this is 142 picometer. Now why this smaller in phenol? This is due to partial double bond character because of resonance. These are the resonatic structure of phenol. You can see in these three structures there is a double bond, this one, okay, and if we consider the resonance hybrid of all these resonatic structure, then there is partial double bond character between this carbon and this oxygen. Partial double bond character means shorter bond length. Actually, when bond order increases, bond length decreases, okay. Another reason is sp2 hybridized state of carbon to which oxygen is attached. As we already discussed, this carbon is sp2. sp2 means more S character compared to sp3. More S character means more electronegative. More electronegative means these shared pair of electrons are more close to this carbon, and this bond is shorter. Shorter bond means smaller bond length, okay. In ethers, the 4 electron pairs, that is the 2 bond pairs and 2 lone pairs of electrons on oxygen, are arranged approximately in a tetrahedral arrangement. You can see this oxygen, this is sp3 hybridized, and it contains, these are the 2 lone pair of electrons and these 2 bond pairs. Arrangement of these 2 lone pair and 2 bond pair is tetrahedral, but again due to the presence of these 2 lone pair of electron, its shape is bend shape, this, okay. The bond angle, now this bond angle COC bond angle, this is slightly greater than the tetrahedral angle. Now again we know normal tetrahedral bond angle is 109.28 degree, but in this case this is 111.7 degree. What is the reason? This is due to the repulsive interaction between the two bulky groups. What are the bulky groups? These alkyls groups. Now in case of methoxymethane, this is methyl and this is methyl. They repel each other. That's why this bond angle is slightly greater than the normal tetrahedral bond angle. Okay. The CO bond length 141 picometer is almost the same as in alcohols, that is in methanol 142 picometer. Now if we compare this bond length, this one, this is 141 picometer and this methoxymethane, and in case of alcohol the bond length of carbon oxygen is also same like 142 picometer, almost same. Okay. Thank you. Subscribe my channel to get the new videos from this chapter.